Hi, let us continue with our discussions about the curtailment of reinforcement in reinforced concrete member. In our previous videos, we have introduced two models used to determine the curtailment of reinforcement. This is the first model. I call it the simplified model. The second model is this, which can be found in Figure 9.2 in Eurocode 2 Part 1. The fundamental principles used by the two models are similar, except there are several areas which are different. Let us first talk about the similarities. The two models can be used to determine the amount of reinforcement bar and where should the reinforcement bar be curtailed. Second, they are both work on the basis of the tensile force diagram, which is derived from the envelope bending moment diagram from the beam analysis. The reinforcements are provided in order to resist those tensile force as a measure to control the cracking in the member. And then the amount of reinforcement bar is curtailed in such a way that the resistance is always greater than what is required. Ensuring along the entire beam span there is no regions with insufficient resistance provided by the reinforcement against the tensile force calculated. Also, both models consider the influence of the anchorage length and recommended that the reinforcements are curtailed after the anchorage length. These are among the similarities between the simplified model and the model given in the Eurocode 2. Now let us talk about the differences between the two models. By knowing their differences, you will gain better understanding about the fundamental principles of doing curtailment of the reinforcement. The differences between the two models are summarized here. First, the simplified model is more simplified as compared to the Eurocode 2 model. However, it is less precise and have narrower applications. Whereas for the Eurocode 2 model, it is more precise and it has a wider applications. The main reasons behind these precisions is the assumption made on the anchorage length. The simplified model assumes no stress development along the anchorage length, as seen here. Theoretically, stress develops along the increment of the anchorage length. Until it achieves the full anchorage length, the full stress is developed within the steel bar. However, the simplified model only considers the full stress developed within the steel bar upon achieving the full anchorage length. Prior to achievement of the full anchorage length, it is assumed no stress developed in the steel bar. This made the estimations to be less precise as compared to the Eurocode 2, where the Eurocode 2 model here consider the stress development along the anchorage length. That's why you see an inclined resistance provided along the anchorage length. The assumptions by the Eurocode 2 model here assume that the stress developed within the steel reinforcement is proportional to the anchorage length. This might not be fully accurate in the reality, which the development of the stress along the anchorage length most likely will be in the mode of the parabolic in the reality. For simplicity, Eurocode 2 model assume a linear development in terms of the stress, which is good enough and more accurate as compared to assuming no stress development by the simplified model. Next, you see the simplified model has a narrower applications than the Eurocode 2 model. The reasons lie in the determinations of the envelope tensile force diagram. If you see the curved tensile force diagram in the simplified model, it is determined based on the MED per Z. MED comes from the envelope bending moment diagram, whereas the Z here is the section modulus. Now, if you compare with the Eurocode model, there is an addition of the NED, which is the axials acting onto the member. This NED can induce tensions or compressions to the member, which can result in positive or negative NED, leading to shiftings of the MED per Z. To make it simple, the simplified models is only applicable for the member, not subjected to any axials. The envelope tensile force diagram is derived fully based on the bending moment diagram divided by the section properties. However, when it comes to the Eurocode 2 model, it gives considerations on the potential axials acting onto the member. Indicates that the member is not subjected to any axial. We can simply assume this equals to 0. Another difference between the simplified model and the Eurocode 2 model is the calculations to determine the magnitude of the horizontal shift of alpha 1. Both models involve the horizontal shift of the tensile force diagram in the magnitude of alpha 1, as can be seen here, and also here and here. The shifting of the alpha 1 provide considerations of the additional longitudinal force due to shear reinforcement. And then this alpha 1 here is calculated based on the strut and tie models of the shear reinforcement in a beam. Now, if you observe the formulas used to determine alpha 1, this formula is applied to the simplified method, whereas Eurocode 2 method uses this formula. The two formulas looks alike, except Eurocode 2 formulas has an additional of cotangent alpha. We have no issue with the data here because that represents the shear angle. More specifically, the angle of the compressive diagonal thrust of the model, which in this case normally we assume 22 degrees. However, Eurocode 2 has an additional considerations in terms of the alpha, giving the considerations for the usage of the inclined shear reinforcement. In another word, the simplified models only applicable for vertical shearing, whereas the Eurocode model is applicable for both vertical shearing and also inclined shearing. This made the Eurocode model to have a wider applications. Now, because of this series of the assumptions and the differences, you will see the simplified model requiring more reinforcement than Eurocode 2. More specifically, in the simplified model, this is where the shifted envelope diagram ends. Since the simplified model disregards the development of the stress along the anchorage line, you will need to have the reinforcement curtailed after the full development of the anchorage line. Now, if you compare with the Eurocode 2 model, instead of having the anchorage length shifted, the development of the stress within the reinforcement bar can be taken as a resistance to the shifted tensile force diagram. As long as the development stress offers a greater resistance than what is required for the tensile force diagram, you may actually curtail the reinforcement at the tip of the shifted tensile force diagram. Now this makes the differences between the simplified model and the Eurocode model. Bare minimum, the differences it will be equivalent to at least 1 times the anchorage length. Considering the anchorage length on the other side, for one reinforcement bar, the differences may be 2 times the anchorage length, 1 at each end. Next, another difference between the simplified model and the Eurocode 2 model, it will be the overlapping of the anchorage length. For simplicity, simplified models normally try to avoid overlapping of the anchorage length. Something like this. However, for the Eurocode 2 model, overlapping of the anchorage length of the reinforcement is possible, considering the gradual increase in terms of the stress within the reinforcement along the anchorage length. The regions of the overlapping, there will be superpositions of the stress developed within the reinforcement. Then you will have to plot the resistance accordingly and make sure in no regions the provided resistance is less than what is required. This establishes the differences between the two models. Now bear in mind that after you have done the model, identify where you should curtail the reinforcement. You will need to check against the requirements in terms of the serviceability, durability, and detailing. Only then you can finalize the arrangements of the reinforcement in the members, taking into considerations of the minimum amount of reinforcement bar in this section, at least 1 bar at the corner of the beam section, minimum bar size, at least 12 mm diameter, as minimum bar spacing, maximum bar spacing, and so on so forth. Not only that, there are several additional curtailment rules that needs to be complied, which shall be discussed in the following videos. Stay tuned and see you then.